This is not a proper tutorial. This is a quick and dirty recording for the sake of my students of EECE 251 who are having a final exam 2 days from now. In the circuits below in figure 1, this one, and assuming the diodes are ideal, determine the voltage V0 and the current ID in each one of the A, B, C, and D configurations. In the first one, I say plus 5 volts 0. This is lower than that one, so current would be flowing downwards. If this diode was closed, I'm going to assume that the diode is closed, like so. All that remains is to prove that I was right. The current in this circuit, nothing is connected on this wire here, would be 5 minus 0 divided by 2.5 kilo ohms, and that is of course only 2 milliamps. The current is 2 milliamp, and it's positive, so we were right, and the diode is indeed closed. It is closed and the current is flowing like so, and then it's connecting V0 to the reference node. V0 is 0 volts. And in this case, I say this node is higher than this one. The current would try to flow downwards, but the diode will impede that. I would assume as my first approximation that the diode is open. This way, I have to prove that this node here is higher than the node here. In other words, I get to prove that this node, which is the anode and the cathode, anode is lower than this one. Well, let's see. The current is 0. That is part of my assumption. If the current here is 0, there is nothing connected down here. The current here is going to be 0 amps. 0 amps. That means that the voltage here is going to be 0 volts as well. That is, this V0 is 5 volts. 5 volts here at the cathode of the diode, 0 at the anode. Indeed, VAC is -5, which is less than 0, and we were right. The diode is open, the current is 0, the output voltage is 5 volts. The next question, this one. Let's see. This voltage down here is -5, the one up here is 0. -5, 0. If possible, the current would flow from 0 to -5 downhill like this. The diode will impede that. I'm going to assume the diode is open, but we have to prove it. If this is open, the current is going to be 0 amps. But if that is indeed open, then VA is less than VC. Well, let's see what is VA. There is no current here, so V0 is going to be -5 volts as well. -5 volts. The current here is 0. The voltage here is 0, so the voltage V0 is just -5. The voltage of the anode is -5. The voltage of the cathode is 0, so VAC is indeed -5. VAC is -5 volts, which is less than 0. The diode is open. I was right, and that's the solution. 0 amps, -5 volts. For this last one, the voltage here is 0, the voltage here is -5. If possible at all, the current would be flowing from high to low, from 0 to -5, would flow downhill. And that would be possible only if the diode is closed. I'm going to assume that it's closed, like this. But we have to verify that that is correct. If this is the circuit, the current is going to be 0 minus -5. That is plus 5 divided by 2.5 kilos. That is 2 milliamps. That is the current, 2 milliamps. But this ideal diode is connecting V0 to the reference node, so this voltage is going to be 0 volts. And that's the solution for this question. Let's move on to question number 2. Using the simplest of the real diode models seen in class, find the diode current ID and the diode voltage VD for the circuits in figure 2A and 2B below. Observe that the diode in 2A is a germanium diode and the one in 2B is a silicon-based diode. The simplest of the real diode models seen in class is the one that represents the diode as a V source in series with an ideal diode. 0.3 volts for the germanium and 0.7 volts for the silicon. So I'm assuming this diode is conducting. It's behaving as a 0.3 volt V source, and we solve the network. Let's see, what is this current here? That current is 16 minus 0.3 divided by 5.1 kilo ohm. This is this current, and the current in this resistor would be 0.3 divided by 4.7 kilo ohms. We subtract them to get what is the current in the diode ID. And that is, in this case, 302 milliamps. So the current is positive, flowing the way we want it. It's sufficiently large. Indeed, the diode is conducting. The current is flowing in the right direction. Let's assume the diode in figure 2B, the silicon-based one, is also closed. Then we'll represent it with a V source of 0.7 volt. So the current in the diode is computed as the current up here, 16 minus 0.7 divided by 4.7 kilo ohms, minus the current in this resistor, which is 0.7 divided by 100 ohms. But when we compute the current like that, the current in the diode turns out to be a negative one, negative 3.20, no, 0.7 milliamps. Negative? And that is impossible. Of course, that is wrong. What that signifies is that the diode actually is open and the current is 0 amps. If the current here is 0 amps, then what we have is a voltage divider of 16 volts between those two resistors, and the voltage in the diode in that case would be 16 times 100 divided by 4.7 kilos plus 100 ohms, 1/3 of a volt. Of course, the diode is open, it's off, the current is 0, and the voltage across it is a mere 1/3 of a volt. Now we proceed to question number 3. Using the simplest of the real diode models seen in class, compute the diode current ID and the output of voltage V0, this one, in each one of the two circuits in the figure 3 below. Well, I'm going to assume that both diodes are conducting. Here plus 16 looks like that, and the same is true here. If they're conducting, the simplest of the real diode models is the V source. So 0.7 volts for the silicon one and 0.3 volts for the germanium one. That means that in this circuit, V0 is 16 minus 0.7 minus 0.3, V0 is just 15 volts. And the current? Well, the current is just 15 divided by 1 kilo. That is 15 milliamps. What about the second circuit? The same thing, 16 volts is trying to push current in the direction of the diodes. I'm going to represent this one with a V source of 0.7 with 0.3. Like this. And we solve the circuit. Of course, the current is going to be, in this case, 16 minus 0.7 minus 0.3 divided by 2 plus 1 kilo is 3 kilo ohms. That current in the diode in this case is going to be 16 minus 0.7 minus 0.3 divided by 2 kilos plus 1 kilo. 5 milliamps. That is the current, 5 milliamps. What about the voltage V0? Well, 5 milliamps in this 1 kilo ohm resistor produces a drop of 5 volts plus 0.3. V0 is 5.3 volts, of course. And that is the answer to this question. Question number 4. For the two configurations in figure 4, and assuming that inputs V1 and V2 can be either 5 volts true or 0 volts false, and considering also that any voltage below 2.5 will be deemed a false logic value, and any voltage above or equal to 2.5 volts will be deemed a true logic value, demonstrate that something's wrong here, that one of them is a logic OR gate and the other is a logic AND gate. Which one is which? Suggestion: build a truth table for all possible input and outputs. That is what I'm going to do. So for this one, this circuit, two inputs, V1 and V2, and this is the output V0. The possible inputs are of course 4. Both of them are false, 0 and true. This is true and false, or both are true. If both are false, 0 and 0 volts, those diodes are going to be open. There's going to be no current, there's going to be no voltage drop in this resistor, so the voltage V0 is going to be the reference node, 0 volts. It's a false. False, false, output false. Now, if one of them is false and the other is true, well, I apply 5 here on V2. I'm going to assume that this closes, because 5 and 0 down here, it's going to flow like that, the current, that's right. What about the 0 here? This is connected to the reference. Now this is a wire, all of this is at 5. 5 here, 0 here, this will remain open, no problem. So V output is going to be 5, it's going to be a true. What about here? Well, the same thing is true in this case. And if both of them are 5, both are on, both close, the current flows, and more the reason for V0 to be 5 volts. This is an OR gate. Let me write here, this is an OR gate. And for this one, again the same thing. And let me create input V1, V2, and V0 is the output. So the possible inputs, both are 0. If both are 0, because the voltage here is plus 5, this would be at the reference level, current would flow. This would be closed diodes connecting the output to 0. The output would be 0 if both are 0. If one of them is 0, the same thing is true. They are connecting the output to the reference node. But if both of them are at 5 volts, there will be no difference of potential across the anode and the cathode. The diode will remain open, the current will be 0 volts here, so the output will be the voltage of the power supply of here, 5 volts. This is an AND gate, and this is the answer to this question of the assignment.